All right, so we've tackled power rule, product rule, and now we're going to tackle quotient rule. So quotient, just like it sounds, a quotient is when you are dividing two functions. So typically we're going to see when we say two functions, we want to see two x's. So something like f of x divided by g of x. So again, I want to stress again, just kind of similar to product rule, there has to be an x in the numerator and an x in the denominator. So you can make a little note for yourself. We do want to make sure we see two x's. So some examples of quotient rule versus not quotient rule. Quotient rule would be something like x plus 4 over x minus 2. Again, I have that x in the numerator, x in the denominator. Sine of x divided by the cosine of x. X in the numerator, x in the denominator. Not a quotient rule. X plus 4 divided by 7. I am not using quotient rule at this point because there is no x in the denominator. Okay, so again, this is not a quotient rule example. So the rule for quotient rule and the saying that you're going to want to use, of course. So if I want to derive a quotient, so if I want to derive f of x divided by g of x, okay, I'm going to give you the phrase and then we'll write it out. So the phrase you want to say, and this is just a common calculus phrase, we didn't make this up. It's called low d high minus high d low all over low squared. So low d high minus high d low all over low squared. So what does that mean exactly? Well, kind of like it sounds. You're going to start with the low. So my low is g of x. D high means derive the high. So the derivative of the high, the f of x, is f prime of x minus, so product rule had a plus sign, quotient rule has a minus sign. The high term, f of x, d low, derive the low, so g prime of x, all over means divided by the low term squared. Now notice how I'm taking that low term inside a nice big bracket and squaring it. Okay, so kind of start singing it to yourself. I literally, till this day, I've been doing calculus for 20 years, and I still say low d high minus high d low all over low squared. You just keep repeating that phrase to yourself throughout the problems. So let's go ahead and tackle the first question. F of x equals 5x minus 2 divided by x squared plus 1. So again, I just want to check that it's a quotient rule problem. There's an x in the numerator, x in the denominator, so I know I can use quotient rule. So we'll just kind of start singing it to ourselves. Low, so f prime of x equals low. Now again, notice how I'm using parentheses around every set of terms. Low d high. So now using the power rule, the derivative of 5x minus 2, well, that's linear, so that's just 5. Minus high. The d low, x squared becomes 2x. So low d high minus high d low all over the low, which is the x squared plus 1 squared. Okay, so once you go through that process, the calculus part again is over. You did the calculus. Now it's just cleaning up the algebra. And obviously there's easy places to make mistakes there, but we just want to slow down as best we can and work on our algebra skills there. So I'm just going to distribute kind of that 5 through. So it's going to get me 5x squared plus 5. And I'm going to leave that in parentheses, a lot of parentheses in quotient rule. Minus, and the reason is because of this minus sign. I'm going to distribute this. So in parentheses, I get 10x squared minus 4x all over. I'm going to leave it as x squared plus 1 squared. You don't really need to FOIL that out. But we really need to watch those parentheses on the top row because we have to be very, very careful that we now take this negative and distribute it through. And again, that's where, students are going to make mistakes and we don't want to be one of them. So I have 5x squared plus 5. Distribute this, so I've got minus 10x squared plus 4x all over this denominator squared. And let's see if I have some room down here. Let's see, so my like terms, that's going to be negative 5x squared plus 4x plus 5 all over the x squared plus 1 squared. And there you have f prime of x using the quotient rule. So low d high minus high d low all over low squared and lots of parentheses. All right, number 2. H of x equals 6x squared plus 3x minus 5 over 3x. I'm going to take a look at it and I'm going to say, okay, I have x's in the numerator, x's in the denominator. So we can go ahead and apply quotient rule. So let's kind of sing our song. Low, d high. So 6x squared becomes 12x plus 3x is linear, so plus 3. 5 is a constant, it's gone. Low, d high minus high. D low, 3x is linear, so it's just derivative is just 3, all over the low squared, and it's wrapped up in parentheses. And again, I'm just in my cleanup phase here. So calculus is done, we're just cleaning up. So that's 36x squared plus 9x, wrap it up, minus, keep this side wrapped up. So that's going to get me 18x squared plus 9x plus, minus 15. All over that denominator squared. I'm going to keep going here. So I have h prime of x equals, so that's oh dear, what did I hit? Scratch that. 36x squared plus 9x minus 18x squared minus 9x plus 15 all over. Now I can square this because 3x times 3x makes 9x squared. So like terms, I have 36x squared minus 18x squared is 18x squared. The 9x's cancel plus 15 all over 9x squared. And it looks like I can divide each of these terms by a 3. So I've got 6x squared plus 5 all over 3x squared. So that is one solution. Now here's where you can get a little sneaky with this. You can make like a beaver and split. So I can divide these in my cleanup. I can say 6x squared over 3x squared plus 5 over 3x squared gets me, that divides to 2 and those cancel. 2 plus 5 over 3x squared. Now, I do want to go back because quotient rule can get a little sneaky because actually this really isn't a quotient rule problem. Although we applied quotient rule and we said both the top and bottom have x's, the smarter move would have been to make like a beaver and split here. And why can I split? Because I have one term on the bottom. And when it comes to this calculus exam, it's all about time. So obviously, if this is a bridge was actually happening for real, and not COVID-19 here, we'd have a million quizzes just kind of drilling these things in your head, and we'll have them throughout the school year when we meet. But it's really just about timing. So I want to kind of go off to the side and just attack this problem with a split to show you what a time saver it is. So anytime you can split, you want to make sure you do so. And again, I can split when there is one term in the denominator. So watch the split and watch how much easier my life became. So I have 6x squared over 3x plus 3x over 3x minus 5 over 3x. So it's just a little rewriting. 6 divided by 3 is 2, x squared over x. So this becomes 2x. Those cancel to a 1. And this becomes minus 5/3, right? That's the number, 5/3. And I'm going to bring that as x to the negative 1. Now we'll just take the derivative with the power rule. 2x becomes 2 because that's linear. The 1 becomes a 0. This becomes a 5/3 positive. When I bring that down, x to the negative 2. And look how much quicker I got that same answer without having to go through quotient rule and worry about screwing up any parentheses. All right, so anytime you can make like a beaver and split, anytime there's one term on the bottom, we want to make sure we do so. All right, question 3 here, we want to find both eventually the first and then probably the second derivative. So it's not one term on the bottom, so I can't split, but I do have an x on the top, an x on the bottom, so I know I'm going to apply quotient rule. So just kind of sing it to yourself. Low d high minus high d low all over low squared. So my low d high. The derivative of x, which is linear, is 1, plus the high. I need the d low. The derivative of again of x is 1, and the 1 becomes a constant, all over the low squared. Well, the 1 is a constant, it becomes 0. And the calculus part's done. It's just the cleanup. I'm going to multiply the first two terms. So I've got x minus 1 minus, oh dear, low d high minus high d low all over low squared, minus the x all over the x minus 1 squared. So my x's are going to cancel. So on numerator, I'm getting x minus 1 minus x all over the x minus 1 squared. So I'm left with negative 1 all over x minus 1 squared. Now I'm going to find the second derivative. So I'm just going to rewrite that first for myself. And I'll be able to take the second derivative. So I'm going, even though there's not an x on the top, we haven't learned the next trick, so I am going to apply quotient rule here. So I'm going to go low d high, so the derivative of a constant is 0, which is great, low d high, minus the high, notice it's in parentheses, times the derivative of the low. Now here's my problem. This is not a power rule. X minus 1 squared is not power rule because it's not x to a power. So I have to clean this up. So I can say this is equivalent to, if I FOIL that out, x minus 1 times x minus 1. I'm hoping you can FOIL in your head. Square the first. Multiply those together and double it. So minus 2x. And then square the last, plus 1. So then I need its derivative. So 2x minus 2 all over the low, which is x minus 1 squared squared. So low d high minus high d low all over low squared. And again, I'm just going to work on cleaning this up. Anything times 0 is gone, so that's beautiful. Negative times a negative is a positive, and that's 1, so that just stays 2x minus 2. And then power to a power, you can multiply. So you can call this x minus 1 to the 4th. And then we're good to go there. All right, so here's a new piece for us. Determine the x values at any at which there is a horizontal tangent line. Okay, so we haven't talked about this before. So grab your highlighter and let's talk about that word horizontal tangent line. Okay, so remember, the whole course is about slope. If you get confused, just say, what is the slope? That's what they keep asking about. The whole course. Calculus is all about slope. Slope says rates of change. So if I said a horizontal tangent line, just draw a horizontal line for yourself. Okay, and then just ask yourself, what is the slope? Because that's what the whole course is about. The slope of any horizontal line. Okay, think of it as a skier. Does it have any slope to it? No. This slope is 0, the slope of a horizontal line. So it says determine the x values. So you don't know x. You're not plugging this into x. You don't know it. Determine the x values at which the function has a horizontal tangent line. So they're basically saying, when does the slope equal 0? That is the question. When does the slope equal 0? So it would have been nice if they just asked that, but they're asking it in their own way. Horizontal means slope of 0. Okay, so I need to find the slope, which means I need to take the derivative. So here's my game plan. I need to derive. Okay, take the derivative. And I want to set the derivative equal to 0 because I want to know when the slope equals 0. So I guess my question to you is this product rule or can you make like a beaver and split? So, or quotient rule, I should say. Since there is one term on the bottom, I'm going to do the split trick. So I'm going to first rewrite f of x as a split. So I'm going to say 4x cubed divided by 2x. And if you can do this part in your head, go for it. I'm just, again, showing it for anyone that's stuck. So if you can jump to this line, that's fantastic. I'm going to say that's 2x squared, if you can just divide those in your head, minus 5x. Okay, so I have my cleaned up function. Now I'm going to take its derivative. So bring that 2 down. So I've got 4x minus, this is linear, so minus 5. So the question says if I want a horizontal line, I want the slope to equal 0. So I'm setting 4x minus 5 equal to 0 and just solving for x. So I'm going to add that 5 over. So I have 4x equals 5. Therefore, x equals 5/4. So the question said determine the x value, if you can find one, where you have a horizontal tangent line. So when the function is at 5/4, there is a slope of 0. There is a nice flat line, a slope of 0. Since this was a parabola, maybe I should make it look like a parabola. There is a nice slope of 0 there. All right, so 2 pieces to this question. Write the equation of the tangent line and the normal line at the given point. So I'm hoping this is fairly easy by now. Anytime you see equation of a line, you want the x, the y, and the slope. You need a point and a slope. So the non-calculus is the one I usually grab first. If x is 2, again, I'm just substituting in 2 to get that y value. 2 minus 1 all over 2 plus 1. So I've got 1/3. So there's my point. And then here comes the calculus. When you want the slope, we now do the calculus. So if I look at this function, it's a fraction, it's a quotient. There's an x on top, there's an x on the bottom, and I cannot split because it's not one term. So I'm just going quotient rule. So here we go. Low d high. The derivative of x minus 1 is just 1. Low d high minus high d low all over the low squared. And I'm going to clean that up. So f prime of x equals x plus 1 times 1 is x plus 1 minus x minus 1 times 1 is x minus 1. Notice how I have parentheses. That's the key, of course. All over the x plus 1 squared. I'm going to clean up the top. So I have x plus 1 minus x plus 1 all over the x plus 1 squared. So it looks like I get a slope of, those cancel, 2 over x plus 1 squared. And they specifically want the slope when x is 2. So now I'm just going to find f prime of 2. So I've got 2 over 2 plus 1 is 3. 3 squared is 9. So if my slope is 2/9, then we're almost done. We just need to write our workout. My tangent line would be y minus 1/3 equals 2/9 times x minus 2. And my normal line, remember, is just that fancy word for perpendicular. So I'm only changing the slope to a negative and flip that fraction 9/2 x minus 2. And there you have it for both the tangent and the normal. All right, we've made it to our last question of the day. It has 4 little pieces here. And again, this is function notation. We're just going to see a lot of it this year. We want to find the derivative at 2. So we want to derive each of these and plug in 2. So f becomes f prime. All right, so just to review, this is not a product rule because the 2 does not have an x. There are not x's with it. So it is just keep the coefficient of 2 times g prime of x plus h prime of x. And then if I want f prime of 2, I just carefully substitute in 2 times g prime of 2 plus h prime of 2. So that's 2. G prime of 2 is negative 2. H prime of 2 is 4. Looks like I get 0 there. Negative 4 plus 4. Going to 18. Derivative of f is f prime. The derivative of 4 is a constant, so you get 0. I'm going to keep my minus sign, and h becomes h prime of x. So if I want f prime of 2, I'm looking at negative h prime of 2. So I'm looking at negative, and h prime of 2 is 4, going with a negative 4. 19, I've got a fraction with x's in the top and bottom, so I'm saying to myself, low, d high, derive the high, minus high, d low, all over the low, wrap it up carefully and square it. And then we'll just carefully substitute in all of those 2's. So I've got h of 2 times g prime of 2 minus g of 2 times h prime of 2 all over h of 2 squared. All right, so h of 2, so I've got negative 1 times g prime of 2 times negative 2 plus 3 times 4. Hoping that looks right. All over h of 2 is negative 1 squared is 1. So I'm thinking I've got, oops, this should have been a minus. Sorry. Low d high minus, I got my minus in there, minus high d low. So I've got 2 minus 12. So I'm going with negative 10. So you can verify that. And then lastly, I have g of x times h of x. So I'm going to go product rule, just a little review here. So product rule was first times the derivative of the second plus the second times the derivative of the first. And again, carefully substitute in all my 2's. G of 2 times h prime of 2 plus h of 2 times g prime of 2. So I've got 3 times 4 plus h of 2 is negative 1 times negative 2. So I've got 12 plus 2. I'm looking at a 14. Okay. All right. So quotient rule, product rule, power rule are the 3 main rules we've covered. And again, we'll have a little practice for you.